Hi, this is David Quatello with Siemens, and welcome to the Basics of Load Centers. This course covers residential power distribution concepts and provides an overview of Siemens residential circuit breakers and load centers. You should have a basic understanding of electrical concepts to fully benefit from this course. Now you can choose to take the course in its entirety, or I have broken it up into 4 separate sections with multiple choice and true and false questions mixed in between. So let's get started. Upon completion of this course, you will be able to explain the role of a load center in residential distribution, define a load center, distinguish between the terms panel board and load center, explain the need for circuit protection, identify various components of a Siemens load center, distinguish between a main breaker and main lug only load center, identify various power supply systems used in residential applications, explain the use of load centers used as service entrance equipment, describe the proper grounding techniques of service entrance and downstream panel boards, identify the types of circuit breakers used in Siemens load centers, and identify Siemens load center products and their features. As mentioned before, this course has 4 parts plus a final exam. The first part is an introduction that covers basic residential power distribution concepts. The second part covers residential circuit breakers with an emphasis on Siemens circuit breakers. The third part covers basic load center concepts, and the fourth part covers Siemens load centers and other Siemens residential power distribution products. The function of a power distribution system is to safely distribute electrical power throughout a building. Power distribution systems are used in every residential, commercial, and industrial building. Most of us are familiar with the power distribution system found in the average home. Power, purchased from a utility company, enters the house through a metering device. The incoming power then goes to a load center, which provides circuit control and overcurrent protection. The power is distributed from the load center to various branch circuits for lighting, appliances, and electrical outlets. Sometimes, particularly when there have been additional construction, a second load center, often called the subpanel, may be installed and powered from the main load center. Careful planning is required so that the power distribution system safely and efficiently supplies adequate electric service for present and possible future needs. The National Electrical Code, NEC, is used extensively in the electrical industry. Article 408 covers panel boards, including load centers. Other articles shown in this illustration cover related topics. Load center is an industry term that applies to the types of panel boards used in residential or light commercial applications. The National Electrical Code makes no distinction between a panel board and a load center. Rules and definitions that apply to panel boards also apply to load centers. A panel board is a type of enclosure for overcurrent protection devices and the buses and connections that provide power to these devices and their associated circuits. According to the NEC, panel boards, including load centers, are used to control light, heat, or power circuits, placed in a cabinet or a cutout box, mounted in or against the wall, accessible only from the front. Load centers are constructed of the following 3 parts: an enclosure, the interior, and the trim. The enclosure is typically constructed of cold rolled steel, that's for indoor use, or galvanized steel for outdoor use. Together with the trim, the enclosure is designed to provide component and personnel protection. The National Electrical Manufacturers Association, or NEMA, has established standards for electrical equipment enclosures. NEMA Type 1 enclosures are intended for indoor use. NEMA Type 3R enclosures are intended for outdoor use, primarily to provide a degree of protection against rain, sleet, and damage from external ice formation. Load center enclosures typically conform to one of these NEMA enclosure types. Knockouts are stamped into the enclosure to provide a convenient means of creating holes for use in routing electrical wiring. Approved cable clamps or conduit hubs are used in the holes to secure and protect the cable and conductors. Knockouts may be removed prior to mounting the enclosure. On multiple ring knockouts, remove the center section by striking at the point furthest from the tie. Bend the knockout back and forth to break the tie. If a larger opening is required, remove each additional ring one at a time by prying with a screwdriver and bending back and forth with pliers as shown in the following figure. The load center interior mounts inside the enclosure and includes bus bars and related hardware. A bus bar serves as a common connection for two or more circuits. In a load center, bus bars are used to make it easy to connect circuit breakers to service conductors and load wiring. Siemens load center bus bars are made of copper or aluminum. The most common method for powering a load center is to connect the load center supply bus bars to the secondary winding of the utility transformer. Even though the secondary winding is providing single-phase power, one side of the secondary is called the A phase and the other side is called the B phase. The center tap connection to this transformer is grounded and becomes the neutral connection. The neutral is a current carrying conductor that connects to the load center's neutral bus. As the accompanying illustration shows, with this configuration, the voltage applied to the load center supply bus bars is 240 volts, but the voltage from the neutral connection to either supply bus bar is 120 volts. The Siemens PL series load centers and some Siemens ES series load centers have dual neutrals, meaning that neutral connections are available on both sides of the load center interior. Dual neutrals are connected together through a neutral tie bar. Dual neutrals are useful, especially on larger load centers, because they simplify load center wiring. InstaWire is a feature found in Siemens PL series and ES series load centers. The InstaWire screw is backed out at the factory, but retained in place by a special feature on the screw thread. This special feature prevents the screw from falling out during shipment or installation. The InstaWire screw head accepts either a standard screwdriver or a square tool bit. InstaWire saves an installer time by eliminating the need to back out every screw and by allowing the installer to use a power tool to tighten the screws. Branch circuit breakers plug directly onto the load center supply bus bars as shown in the accompanying illustration. The label identifies the load center's catalog number, enclosure type, voltage service, and amp rating. Additional information on the label identifies circuit breaker types that can be used with the load center, short circuit current ratings, and wiring diagrams. The trim assembly, sometimes called the dead front, attaches to the front of the load center and covers the interior. The trim assembly includes an access door and an adjustable upper pan. The trim assembly provides access to the circuit breakers while sealing off live parts and internal wiring. The upper pan contains twist outs that cover spaces not filled by a circuit breaker. Twist outs can be removed by twisting them up and down with pliers. All unused openings in the upper pan must be filled with a filler plate. A circuit directory on the door, similar to the one shown here, provides space for listing the services protected by each branch circuit breaker. The enclosure with the interior is mounted to a wall. All incoming and outgoing conductors are connected to the load center. Siemens load centers can be surface mounted or flush mounted. For flush mounting, the load center is positioned so that the front edge of the enclosure is flush with the finished wall. The trim assembly is installed after the wall is finished. Load center installation requires careful planning to ensure a safe environment for personnel and equipment. Article 110.26 of the NEC covers spaces about electrical equipment. The intent of Article 110.26 is to provide enough working space for personnel to examine and maintain energized equipment. Okay, it is knowledge check-in time for part 1 of the basics of load centers. We'll be asking you 5 questions, so here we go. The 2 types of NEMA enclosures available for Siemens load centers are NEMA types A, 1 and 2, B, 12 and 4X, C, 1 and 3R, or D, 3R and 4. Question 2. A dual neutral provides neutral connections on both sides of the load center interior. A, true, B, false. Question 3, we're going to fill in the blank here. Blank screws used for ground and neutral connections in Siemens PL and ES series load centers are backed out at the factory, but retrieved in place by a special feature on the screw thread. Is that A, rapid wire, B, InstaWire, C, quick wire, or D, fast wire? Question 4. The blank assembly provides access to the load center's circuit breakers while sealing off the bus bars and internal wiring from contact. A, front, B, interior, C, trim. Okay, last question in part 1 of the basics of load centers. A/an blank provides space for listing the services protected by each branch circuit breaker. A, circuit directory, B, interior, C, twist out, or D, bus bar. Now that you've just completed part 1 of the basics of load centers, let's move off to part 2, which covers residential circuit breakers. Current flow in a conductor always generates heat. The greater the current flow, the hotter the conductor. Excess heat is damaging to electrical components. For that reason, conductors have a rated continuous current carrying capacity, or ampacity. Excessive current is referred to as overcurrent. An overcurrent may result from a short circuit, overload, or ground fault. Load centers use circuit breakers to provide protection against short circuits and overloads. Most residential circuit breakers do not provide ground fault protection. A short circuit occurs when 2 bare conductors touch, causing the resistance between the conductors at that point to drop significantly. This reduction in resistance causes current to rise quickly. An overload is typically a much lower current than a short circuit. An overload occurs when too many devices are connected to a circuit, or when electrical equipment is made to work beyond its rated capabilities. Circuit breakers provide a manual means of energizing and de-energizing a circuit and automatic overcurrent protection for that circuit. Unlike fuses, which must be replaced when they open, a circuit breaker can be reset once the overcurrent condition has been corrected. A simple push of the handle to the off, then back to the on position restores the circuit. If a circuit reopens upon reset to the on position, a qualified electrician should be consulted to determine the problem. Circuit protection would be unnecessary if overloads and short circuits could be eliminated. Unfortunately, overloads and short circuits do occur. To protect a circuit against these currents, a circuit breaker must determine when a fault condition develops and automatically disconnect the electrical equipment from the voltage source. Slight overloads can be allowed to continue for a short time, but as the current magnitude increases, the circuit breaker must open faster. Short circuits must be interrupted instantly. A circuit breaker's pole number indicates the number of circuits which supply current through the circuit breaker. For example, a one-pole circuit breaker carries the current for one circuit, and a two-pole circuit breaker carries the current for two circuits simultaneously. In a two-pole circuit breaker, both circuits are controlled by the same trip unit, so that both poles open at the same time when an overcurrent occurs. In addition, both circuits are mechanically interlocked, so that they can be manually opened or closed at the same time. Every circuit breaker has ampere, voltage, and interrupt ratings. The accompanying chart shows the ratings for some typical one-pole and two-pole residential branch circuit breakers. The ampere rating defines the maximum continuous current a circuit breaker can carry without tripping. Because the function of the circuit breaker is to protect circuit conductors, the appropriate ampere rating for a circuit breaker is dependent upon the ampacity of the conductors in the circuit. Each circuit breaker also has a voltage rating, which indicates the maximum voltage it can handle. In other words, the voltage rating of a circuit breaker must be at least equal to the circuit voltage. Some circuit breakers have what is referred to as a slash voltage rating, such as 120/240 volts. In such cases, the breaker may be applied in a circuit where the nominal voltage between any conductor and ground does not exceed the lower rating, and the nominal voltage between conductors does not exceed the higher rating. In residential applications, the most common power distribution system is the one-phase, three-wire system described later in this course. In these applications, a one-pole branch circuit breaker protects a 120-volt branch circuit, and a two-pole circuit breaker protects a 240-volt branch circuit. A circuit breaker's interrupting rating is the maximum available fault current which the breaker is designed to interrupt. The most common interrupting rating for residential circuit breakers is 10,000 amps, often shown as 10 kA. However, as shown in the accompanying graphic, circuit breakers with higher interrupting ratings are also available. It is important to note the difference between a main circuit breaker and a branch circuit breaker. The main breaker of a load center shuts off power to the entire load center and all circuits supplied by that load center. The main circuit breaker ratings determine the overall ratings of the load center. Siemens offers a wide selection of load centers equipped with a main circuit breaker as well as main lug load centers. Siemens PL series load centers are convertible from main lug to main breaker or vice versa. Residential circuit breakers are typically one-pole, two-pole, or full-pole breakers with current ratings of 225 amps or less and voltage ratings of 120 volts, 120/240 volts, or 240 volts. Because residential circuit breakers are also used in some commercial applications, and many commercial applications require three-pole breakers, some three-pole breakers are also included in this category. The most common branch circuit breakers used in Siemens load centers are full-sized one-pole and two-pole circuit breakers. However, Siemens also manufactures a variety of other circuit breaker types for use in load center branch circuits. Type QP circuit breakers are full-size breakers available as one-pole, two-pole, or three-pole breakers. Full-size means that each breaker has a width of 1 inch per pole. One-pole QP breakers are rated for 120 VAC and have continuous current ratings from 10 to 70 amps. Two-pole QP breakers are available with a 120/240 VAC rating or a 240 VAC rating. Two-pole 120/240 VAC QP breakers have continuous current ratings from 10 to 125 amps, and two-pole 240 VAC QP breakers have continuous current ratings from 15 to 100 amps. Three-pole QP breakers are rated for 240 VAC and have continuous current ratings from 10 to 100 amps. All type QP circuit breakers have a 10 kA interrupting rating. However, Siemens also offers type QPH circuit breakers with a 22 kA interrupting rating and type HQP circuit breakers with a 65 kA interrupting rating. Some Siemens load centers are designed to accept type QT duplex, triplex, and quadplex plug-in circuit breakers. These breakers are space-saving breakers that are half the width per pole of type QP circuit breakers. This reduced width allows more circuits to be serviced from a load center provided that the main circuit breaker has sufficient capacity. An important use for QT breakers is in cases where additional circuits are being added to an existing load center, but the number of spaces available in the load center is limited. Type QT duplex circuit breakers combine two independent half-inch width breaker poles in a common unit. This unit plugs into one load center stab and requires one panel space. Type QT circuit breakers are also available in triplex and quadplex configurations. Triplex circuit breakers provide a two-pole circuit breaker for 12240 VAC circuits and two independent one-pole circuit breakers for 120 VAC circuits. Quadplex circuit breakers incorporate two common trip, two-pole circuit breakers for 12240 circuits. Each quadplex or triplex circuit breaker requires two panel spaces. A ground fault occurs when a current carrying conductor comes in contact with ground. A faulty appliance or the presence of water in contact with the conductor are examples of possible ways a ground fault can occur. One way ground fault protection is accomplished is by the use of ground fault circuit interrupter receptacles, or GFCI. These are installed in place of a normal receptacle. Another way is with a GFCI circuit breaker such as a Siemens type QPF or QPHF GFCI circuit breaker. Both breaker types are available in one-pole and two-pole versions. Type QPF circuit breakers have a 10 kA interrupting rating, and type QPHF circuit breakers have a 22 kA interrupting rating. Any receptacle connected to the same circuit as the QPF or QPHF GFCI circuit breaker is ground fault protected. A ground fault circuit interrupter compares current on the hot wire with current returning on the neutral wire. Under normal circumstances, the current is equal. When a ground fault occurs, some of the current returns to the source through an alternate path. For example, a ground fault could occur if a hairdryer is placed on a wet surface that provides an alternate path to ground. Anyone coming in contact with the appliance or the wet surface is at risk from the ground fault. If the circuit providing power to the hairdryer is protected by a ground fault circuit interrupter, however, the GFCI will sense the ground fault, open the circuit, and remove power from the hairdryer. GFCI circuit breakers, such as Siemens QPF and QPHF circuit breakers, are intended to provide protection for personnel and are designed to trip when a fault current to ground of 6 milliamps or more is sensed. NEC Article 210.8 describes the requirements for ground fault circuit interrupter protection for personnel in a variety of locations. Some of the more common locations requiring this protection for electrical receptacle circuits include bathrooms within 6 feet of a laundry, utility or wet bar sink, residential garages, unfinished basements, crawl spaces, and outdoors. Ground fault circuit interrupter protection is also sometimes needed to protect equipment from damaging line-to-ground faults. Siemens type QE and QEH circuit breakers provide this protection by de-energizing the circuit when a ground fault of 30 milliamps or more is sensed. Type QE circuit breakers have a 10 kA interrupting rating, and type QEH circuit breakers have a 22 kA interrupting rating. Both breaker types are available in one-pole and two-pole versions. Siemens GFCI circuit breakers mount in a load center in the same way as a standard circuit breaker, except that they have one additional wire, a white pigtail neutral lead, which connects to the load center's neutral bus. These breakers are also equipped with a test button to check the operation of the device after it has been installed. Arc faults are undesired arcs in which current flows in unintended ways, but in residential applications, usually not in sufficient amounts to cause a standard circuit breaker to trip. Arc faults may occur for many reasons, such as worn electrical insulation or damaged wire, misapplied or damaged appliance cords and equipment, or loose electrical connections. In the example shown in the accompanying graphic, a staple was inadvertently driven through the insulation of a wire during construction. This could potentially cause an arcing condition. The arc fault problem is important because each year tens of thousands of fires are caused by electrical problems, and arc faults are one of the leading causes of electrical fires. Because the causes of arc faults are many and often difficult to eliminate, detecting arc fault and shutting down affected circuits before property damage, personal injury, or loss of life occurs is critical. An arc fault circuit interrupter, AFCI, circuit breaker, in addition to providing overcurrent protection, is intended to provide a degree of protection from the effects of arc faults by recognizing the characteristics unique to arcing and de-energizing the circuit when an arc fault is detected. There are two categories of AFCI circuit breakers. The first AFCI circuit breakers developed were branch feeder AFCI circuit breakers that, in addition to providing overcurrent protection, are intended to protect branch and feeder wiring from the damaging effects of line-to-ground arcs and high-energy parallel arcs. High-energy parallel arcs are line-to-neutral arcs greater than or equal to 75 amps. More recently, combination AFCI, or CAFCI, circuit breakers have been developed. Combination arc fault circuit breakers, in addition to providing overcurrent protection, are intended to protect downstream wiring from all three categories of arc faults: line to ground, high energy parallel arcs, and series arcs greater than or equal to 5 amps. Series arcs are arcs on a single conductor. Requirements for arc fault circuit interrupter protection are covered in NEC Article 210.12. Over the years, the wording of this article has evolved. Revert to the appropriate version of the code for your location to determine requirements for AFCIs and CAFCIs. Siemens offers both branch feeder AFCI circuit breakers and combination arc fault circuit breakers. Siemens type QAF AFCI circuit breakers have a 10 kA interrupting rating, and type QAFH AFCI circuit breakers have a 22 kA interrupting rating. Both breaker types are available in 1-pole and 2-pole versions. Siemens AFCI and CAFCI circuit breakers have a white pigtail wire that attaches to the neutral bus. 2-pole CAFCI circuit breakers have 2 test buttons, and all other Siemens AFCI and CAFCI circuit breakers have 1 test button. Test buttons are used to check the device operation after it has been installed. As shown in the accompanying illustration, Siemens CAFCI circuit breakers are equipped with LED trip indicators, which help electricians and homeowners identify the cause of a tripped breaker. Siemens 2-pole CAFCI circuit breaker is intended for a different use than most 2-pole circuit breakers. Instead of being used with one 240 VAC circuit, it is intended for use on 2 1-pole 120 VAC circuits. The 2-pole CAFCI is designed to allow contractors to use multi-wire branch circuits, commonly known as shared neutrals, which help save on installation costs. When using single-pole CAFCIs, a dedicated neutral is required for each circuit, but the 2-pole CAFCI allows electricians to share neutrals between the 2 circuits fed by the breaker. Although the LEDs on Siemens CAFCIs can point an electrician in the right direction for troubleshooting, these AFCIs do not identify the portion of the branch circuit that contains a fault. Arc faults are often intermittent, which can make troubleshooting the branch circuit difficult. In these cases, it is important to determine whether the fault condition exists in the permanent wiring and connected equipment or in a power cord. Siemens IntelliArc diagnostic tool helps to accurately diagnose the circuit in which a fault has occurred. This diagnostic tool can be used with any circuit breaker regardless of brand. When used in conjunction with good troubleshooting techniques, this tool allows an electrician to locate the cause of the fault more quickly, saving money for each branch circuit that must be evaluated. The IntelliArc diagnostic tool provides a visual indication of the type and magnitude of fault. Because the fault may not cause an AFCI to trip for various reasons, i.e. duration too short or current level too low, the tool provides an indication showing how close an event is to causing an AFCI to trip. As shown in the accompanying illustration, the IntelliArc diagnostic tool includes a base unit, which is temporarily wired into a branch circuit, and a handheld unit, which wirelessly communicates with the base unit. As the illustration shows, the IntelliArc base unit can be easily wired into a branch circuit associated with an AFCI, GFCI, or conventional circuit breaker. Today's homes have many electronic devices, such as TVs, stereos, computers, microwaves, etc. These devices are highly susceptible to damage from voltage spikes. Voltage spikes can be generated in the home by appliances, such as vacuum cleaners and other motor-driven devices, spark igniters on gas ranges, furnaces, water heaters, and other equipment. However, the most damaging voltage spikes are caused by lightning strikes. A lightning strike on a power line several miles away still has the potential to cause extensive electrical damage in a home. Lightning strikes on high voltage lines are generally dissipated by utility surge arresters. The average home, however, will experience 8 to 10 voltage surges of 1,000 to 10,000 volts annually. Damage to expensive electrical equipment can be instantaneous if the surge is significant, but even moderate surges over time can cause cumulative damage. An average lightning strike causes a current 25,000 amps. This map shows the approximate average annual number of days with thunderstorms in various regions of the United States. Siemens offers a variety of devices intended to minimize damage from electrical surges. One of these devices provides point-of-entry surge protection and also incorporates two one-pole circuit breakers. Siemens Circuit Breaker and SPD surge protection device replaces two full-size one-pole 15 or 20 amp circuit breakers and provides surge protection for all branch circuits. The circuit breaker in SPD incorporates two red LED indicator lights that illuminate to show that surge protection is provided for all circuits connected to the load center. The circuit breaker in SPD notifies the owner of loss of surge protection by tripping one or both of the circuit breakers. The value of this feature is enhanced by using one of these breakers for circuit protection of frequently used household circuits, so that the circuits controlled by the breaker also indicate the status of the surge protection. If one or both of the circuit breakers have tripped, turn both circuit breakers to the off, then on position. If either light is not illuminated, the device may still be used for circuit protection, but surge protection is no longer provided and the device should be replaced by a qualified electrician. Installation is as simple as mounting a conventional circuit breaker in a Siemens load center. A lead wire is provided to connect the ground side of the module to the load center's neutral bus. It is recommended to position the device in the first position of the load center and connect the lead wire to the first neutral position. Okay, so we've just finished part 2 of the basics of load centers, so let's go ahead and do a knowledge check. Question 1. QT triplex and quadplex circuit breakers each require blank panel spaces. Answers are A, 1, B, 2, C, 3, D, 4. Question 2. The NEC does not require GFCI personnel protection for electrical receptacles in which of the following areas? A, bathroom, B, living room, C, outdoors, D, near sinks. Question 3. An blank is an undesired arc in which current flows in unintended ways, but in residential applications, usually not in sufficient amounts to cause a standard circuit breaker to trip. Is that A, short circuit, B, overload, C, high impedance contact, or D, arc fault? Question 4. Siemens CAFCI or combination arc fault circuit breakers, in addition to providing overcurrent protection, are intended to provide branch circuit protection for which of these types of arc faults? A, line to ground arcs, B, high energy line to neutral arcs, C, series arcs, or D, all of the above? Okay, last question in part 2. Siemens blank provides point of entry surge protection and also incorporates two one-pole circuit breakers. Is it A, AFCI circuit breaker, B, GFCI circuit breaker, C, circuit breaker in SPD, or D, QT duplex circuit breaker? Okay, we are now going to move forward to part 3 of the Quick Step Basics of Load Centers course, and this one is going to cover load centers and load center concepts. There are two major categories of load centers: main breaker load centers and main lug only load centers. Some load centers, such as the Siemens PL series load centers, are convertible from main breaker to main lug only, or vice versa. NEC Article 408.36 requires that a panel board have an overcurrent protective device with a rating that does not exceed the panel board's rating. This overcurrent protective device can be located in the panel board or on the supply side of the panel board. There are exceptions to this rule, so refer to the article directly for additional information. The accompanying illustration shows these two approaches for applying load center main overcurrent protection. A main breaker load center has a main circuit breaker as an integral part of the load center. If a main circuit breaker is located remotely, then a main lug load center could be used. In this example, the main breaker and load center are both rated for a maximum of 200 amps of continuous current. Main breaker load centers are suitable for use in service entrance applications where the incoming supply cables connect to lugs adjacent to the main breaker, which in turn feeds power to the load center and its branch circuits. The main breaker provides a means of manually disconnecting power from the load center and automatic overcurrent protection. As the name applies, main lug only type load centers do not have a main circuit breaker. The incoming supply cables are connected directly to the main lugs and bus bars. One common application for a main lug load center is as a subpanel. For example, a main breaker load center might supply power to a main lug load center located in an area of the home used as a workshop. Keep in mind, however, that the main breaker load center must be sized appropriately to handle the additional load. Main lug load centers are also used in other residential applications where the main breaker is located remote from the load center. For example, main lug load centers are often used in apartment installations where the main breakers and metering equipment are more centrally located. NEC Article 110.9 requires circuit protection equipment to have an interrupting rating sufficient for the available fault current. There are two ways to achieve this requirement: the full rating method and the series rating method. The full rating method requires all circuit protection devices to have an interrupting rating equal to or greater than the available fault current. In single-family homes, the available fault current normally does not exceed 10,000 amperes. This makes it inexpensive to use the full rating method. In some residential applications, the available fault current may exceed 10,000 amperes. For example, in the case of a building with 22,000 amperes of fault current available at the service entrance, the full rating method, as shown in the accompanying example, requires every circuit breaker to have an interrupting rating of at least 22,000 amperes. The series rating method also requires the main circuit protection device to have an interrupting rating equal to or greater than the available fault current, but downstream circuit protection devices connected in series can be rated at lower values. For example, a building with 22,000 amperes of available fault current requires the main breaker at the service entrance to have at least a 22 kA interrupting rating, but downstream branch breakers can have a lower rating. In the accompanying example, the downstream branch circuit breaker has a 10 K interrupting rating. The series rating method is less expensive to the customer because it allows use of branch circuit breakers with a lower interrupting rating. However, series rated circuit breaker combinations must be tested in series in order to be UL recognized. In addition, NEC Article 110.22 requires the series ratings to be marked on the enclosure. In larger installations, such as apartments, condominiums, and commercial facilities, the available fault current is often greater than 10,000 amperes. In these situations, it is common to see 3 breaker series combinations. The main power of an apartment complex, for example, might have 65,000 amperes of available fault current. The main circuit breaker for a modular metering installation must be capable of interrupting this fault current. The tenant main breakers, however, may only have to be rated for 22,000 amperes of fault current, and branch breakers in each tenant load center may only have to be rated for 10,000 amperes of fault current. The incoming utility power for a facility is supplied to service entrance equipment, which controls the distribution of power throughout the facility. Load centers are frequently used as service entrance equipment for a home. Load centers used as service equipment must be listed and labeled as suitable for use as service entrance equipment. Service entrance conductors must have a readily accessible means of being disconnected from the power supply. NEC Article 230.71 specifies that for each set of service entrance conductors, no more than 6 switches or circuit breakers shall be used to disconnect and isolate the service from all other equipment. Normally, a main breaker load center is used as a service entrance panel, and the main breaker provides the means of disconnecting and isolating the service. Main lug-only load centers are not normally used as service entrance equipment because to do so would limit the service entrance load center to no more than 6 circuit breakers. Homes built prior to 1936, especially in rural areas, used a 2-wire supply system. This system provided 120 volts between a hot conductor and a grounded conductor. A 2-wire system is usually inadequate for today's residential electrical demands and is not allowed for new construction. The most common supply system used in residential applications today is a 1-phase 3-wire supply system. This system provides 240 volts from the A phase connection to the B phase connection and 120 volts between either the A or B phase connection and neutral. Load centers can also be used in commercial applications that may require 3-phase power. 2 of the more common approaches for providing 3-phase power in these applications are a 3-phase 3-wire 240 volt system and a 3-phase 4-wire 208/120 volt system. The accompanying illustration shows the utility transformer secondary windings for a 3-phase 3-wire 240 volt system. This system uses a delta transformer configuration with each phase providing 240 volts. There are multiple approaches for 3-phase 4-wire services. The accompanying illustration shows the utility transformer secondary windings for one of the more common approaches, a 3-phase 4-wire 120/208 volt system. This system uses a WE transformer configuration with a grounded neutral. This system provides 120 volts between any phase connection and neutral and 208 volts between any 2 phases. An object that is electrically connected to the earth is grounded, but not all ground connections are intentional. A ground connection can occur accidentally as a result of faulty equipment or wiring. Proper intentional grounding, however, is essential to the safe operation of electrical equipment. When installing a load center, it is important to ground the neutral bus only at the service entrance, as shown in the accompanying illustration. This is accomplished by connecting a grounding electrode to the ground bus or the neutral bus. The ground bus and neutral bus must be bonded to the enclosure at the service equipment, so that both buses and the enclosure are connected to ground. In addition, the grounded neutral connection from the power source is also connected to the load center neutral bus. Bonding in this context is the joining of metallic parts to form a low-resistance electrical connection. This is often accomplished through the use of a bonding screw that connects a bus to a metal enclosure. Depending on the equipment design, a metal bonding strap may also be required. Siemens PL Series and ES Series load centers incorporate a pre-positioned bonding screw that eliminates bond strap/screw assemblies and reduces the risk of losing components in the field. The neutral conductor is only directly connected to ground at service entrance. When a downstream panel is used, the neutral is insulated and isolated in that panel. The downstream panel must have a good ground connection bonded to the enclosure. The equipment ground conductor connects the downstream panel to the ground at the service entrance panel. The accompanying example shows the downstream panel powered through a 2-pole branch circuit breaker, but for some load centers, sub-feed lugs may be used instead. For simplicity, only one 120-volt load is shown in each panel. Okay, we have completed part 3 of the Quick Step Basics of Load Centers course. Let's go ahead and do a knowledge check. Question 1. 2 major categories of load centers are main breaker and main lug only. A, true, or B, false? Question 2. The blank rating method requires selection of all circuit protection devices with individual ratings equal to or greater than the available fault current. A, series, B, full, C, parallel, or D, compound. Question 3. NEC specifies that a maximum of blank switches or circuit breakers shall be used to disconnect and isolate the service from other equipment. A, 4, B, 5, C, 6, D, 7. Okay, this is the last question. When installing a load center as a sub-panel downstream from the main load center, it is important to ground the downstream load center only at the service entrance. Is that A, true, or B, false? Now that we've completed Section 3, let's move on to Section 4 of the Basics of Load Centers. This particular section covers Siemens load centers and other Siemens residential power distribution products. Siemens offers 2 primary load center product lines, the PL and the ES series load centers. The PL series load centers offer the following features. They are convertible from main breaker to main lug and vice versa. They're invertible for bottom feed applications. Insta-wire neutrals and grounds. Ground bus bars are included. Copper bus bars. Dual neutrals on all configurations. Carton and carton packaging with trims packaged separately, as well as a lifetime warranty. The ES series load center offering offers the following features. Invertible for bottom feed applications, Insta-wire neutrals and grounds, aluminum bus bars, single-sided neutral on load centers with 24 circuits or fewer, single-piece carton, and a 10-year warranty. The PL series load centers have been engineered for quick and easy installation. Here are some examples of PL series installation features. The Siemens patented Insta-wire screws on neutral and ground buses are captive to prevent loss of screws and backed at the factory to speed wire installation. A bonding screw is pre-positioned and designed to avoid the need for bonding straps or separate screw assemblies. 2 ground bars are factory installed on all PL load centers. Slot, square, combination screw heads on the neutrals, ground, trim, upper pan, and bond screws provide installation flexibility. The interior can be easily inverted for bottom feed application. Load center mains can be converted from main breaker to main lug and vice versa. Mounting tabs on the trim hold it in place during installation to free up both hands when driving trim screws, and the outdoor enclosure has a side hinge for easy installation. The PL Series Load Center product line provides a wide variation to meet any application need. The following items summarize the range of capabilities: 1-phase or 3-phase mains, main breaker or main lug, 12 to 70 circuits spaces, indoor and outdoor enclosures, 100 to 225 amp current ratings, unassembled offering for 3-phase. ES Series load centers have been engineered for quick and easy installation. Here are some examples of ES Series installation features. The Siemens patented InstaWire screws on neutral ground are captive to prevent loss of screws and backed at the factory to speed the wire installation. A bonding screw is pre-positioned and designed to avoid the need for bonding straps or separate screw assemblies. Slot, square, combination screw heads on the neutrals, ground, trim, upper pan, and bond screws provide installation flexibility. The interior can be easily inverted for bottom feed application. Main lug and main breaker load centers are available, but mains are not convertible. Mounting tabs on the trim hold it in place during installation to free up both hands when driving trim screws, and the outdoor enclosure has a slide hinge for ease of installation. The ES Series Load Center product line provides a wide array of variation to meet any application need. The following items summarize the range of capabilities: 1-phase or 3-phase mains, main breaker or main lug, 12 to 70 circuit spaces, indoor and outdoor enclosures, 100 to 225 amp current ratings, and also value packs, which are a mix of branch breakers provided with the load center. Siemens EQ 300 to 400 amp main breaker and 400 amp main lug load centers are available for 1-phase, 3-wire, 120 240 volt, and 3-phase 3-wire and 4-wire 240 volt applications. Load center sizes range from 24 to 42 circuits. Both indoor NEMA 1 and outdoor NEMA 3R enclosures are available. Siemens EQ small circuit load centers are 1-phase 3-wire 120 240 volt load centers available with main lugs or main breaker and copper bus or main lugs and aluminum bus. Both indoor NEMA 1 and outdoor NEMA 3R enclosures are available. EQ small circuit load center sizes range from 4 to 20 circuits, 100 to 200 amps. Among the products included are renovation and spa panels. Renovation panels are ideal for older home projects where the distance between studs is narrower than the current construction practices. This narrower panel eliminates the need to notch out the existing studs. Spa panels are intended for outdoor applications, such as hot tubs, that require ground fault protection. A factory-installed 2-pole GFCI breaker is provided along with 2 extra circuits. Siemens EQ circuit breaker enclosures are designed for use with the QP, QT, QPH, HQP, BQ, BQH, HBQ, QPP, QPPH, HQPP, QJ2, QJH2, and QJ2-H circuit breakers. Both indoor NEMA 1 and outdoor NEMA 3R enclosures are available. EQ circuit breaker enclosures for 1-phase 3-wire 120 240 volt applications are available with ampere ratings from 60 to 225 amps. EQ circuit breaker enclosures for 3-phase 3-wire 240 volt and 3-phase 4-wire 120 208 and 120 240 and 240 volt applications are available with 100 or 225 amp ratings. Siemens Generator Ready Load Center is a 200 or 225 amp, 30 circuit, 42 space load center that provides an effective solution for implementing generator backup of critical circuits. Both main lug and main breaker versions are available with indoor NEMA 1 or outdoor NEMA 3R enclosures. Main lug load centers are convertible to main breaker load centers and vice versa with the appropriate conversion kit. These load centers are equipped with two interiors. Up to 30 critical circuits are wired to the lower interior. Non-critical circuits are wired to the upper interior. Both interiors are powered by the electrical utility during normal operation. When utility power is not available, the critical circuits connected to the lower interior can be switched to generator power. In order to accomplish this, an automatic transfer switch or a manual transfer switch must be installed. The switch, along with any branch circuit breakers required for the application, must be ordered separately. However, installing the load center without the transfer switch is a cost-effective approach for new construction when a generator will not be initially installed. This approach allows the wiring needed for standby generator operation to be completed during initial construction. At a later time, the homeowner can install a standby generator without the cost of rewiring. Riser panels are intended for use in high-rise applications. The interior in riser load centers is shifted to the left to allow extra room for riser cables to pass through. Siemens main lug riser panels are available with 125 or 200 amp ratings. Main breaker conversion kits are available. The panels may be mounted with main lugs on top or inverted to allow cables to pass on the opposite side. The riser panels are one-phase only, but can be fed from one-phase or three-phase systems running through the gutter. The riser gutter tap kit allows the installer to tap off the main conductors. Where an existing Siemens one-phase or three-phase load center, 24-inch or larger, is used in place of the riser panel load center, the riser gutter can be installed to convert the load center to a riser panel. Load center mounting hardware, a pass-through brush, and flush trim are included. Siemens load centers have an 8-part catalog numbering system. However, parts 7 and 8 may be blank depending upon the load center configuration chosen. Part 1 identifies the type of enclosure or the component being specified. Part 2 identifies the maximum number of 1-inch circuit breakers that can be installed. Part 3 identifies the maximum number of circuits. Part 4 identifies the type of main. Part 5 identifies the power system. Part 6 identifies the main ampere rating. Part 7 identifies the type of trim and other characteristics. And Part 8 identifies the type of bus bars. The accompanying example, a P1224B1100SCU, is for a load center with the following characteristics: a PL series indoor Type 1 enclosure, a maximum of 12 spaces for 1-inch breakers, maximum of 24 circuits. Its main breaker, it's single phase, it's 100 amp rating, surface mount, and comes with copper bus bars. Careful planning is required so that the distribution system safely and efficiently supplies adequate electric service to both present and possible future loads. As part of this planning, procedures in the NEC should be used to correctly size the load center based upon the following characteristics: general lighting, and that's based on the square footage of living space; small appliance loads, laundry circuits, large appliance loads, and any miscellaneous appliance loads. In addition to load centers and circuit breakers, Siemens also offers a full range of other products used in single-family and multi-family residential applications. Siemens manufactures fused, non-fused, and molded K-switch air conditioning AC disconnects. These are supplied in a NEMA Type 3R enclosure. Both steel and plastic enclosures are available. The fused pullouts are 240-volt, 2-pole, 30 or 60 amps. The non-fused pullouts are 240-volt, 2-pole, 60 amps. The molded K-switch disconnects are 240-volt, 2-pole, 50, or 60 amps. Molded case switch disconnects are supplied with non-automatic QP molded case switch circuit breakers. For many years, power companies have used a familiar watt-hour meter to determine how much electricity has been consumed for billing purposes. Each watt-hour meter requires a meter socket to safely and securely connect it to the electrical service. Because meter designs and utility requirements vary, Siemens offers a variety of single-position and multiple-position meter sockets. Single-position meter sockets are used for single-family homes and in some commercial applications. Multiple-position meter sockets, also called gang sockets, are used in multifamily and other commercial applications requiring 2 to 6 meters. Requirements for meter sockets with maximum voltage ratings of 600 volts or less and continuous current ratings of 320 amps or less per socket are covered by American National Standards Institute Standard C12.7 and UL Standard 414. Equipment Utility Service Requirements Committee, or USERC, is an organization of approximately 80 utilities in 12 western states. One of the functions of USERC is to specify manufacturing and installation requirements for metering and service equipment. Utility companies dictate when USERC conforming equipment must be used, but USERC equipment can also be used in areas where it is not required by the utility. Siemens meter combos include 2 product families, meter mains and meter load center combinations. Each family is further divided into USERC approved and non-USERC products. All products are UL listed as suitable for use as service entrance equipment and have padlocking provisions. Continuous current ratings for all 4 categories of Siemens meter combos range from 100 to 400 amps, except for meter load center combinations which range from 125 to 400 amps. A meter main is a meter socket combined with a main circuit breaker in one enclosure. This arrangement is sometimes required by utilities because it places the main breaker external to the residence, making it easier for service personnel to disconnect power. A meter load center combination is a meter socket combined with a main breaker and load center. However, when only 6 or fewer branch circuit breakers are needed, the NEC does not require a main breaker. Meter load center combinations are gaining in popularity because having the meter socket, main breaker, and load center in one location allows contractors to save on labor and material. Unipack meter centers are an option for multifamily dwellings and other commercial applications. These are self-contained systems with 2 to 6 meter compartments. Individual branch circuit breakers for each tenant are located in a separate compartment adjacent to each meter socket. PowerMod modular metering is used for multifamily dwellings or other commercial applications requiring more than 6 meters. As the name indicates, PowerMod incorporates modules that can be quickly combined to meet varied application requirements. Basic modules include circuit breaker mains, fusible switch mains, tap boxes, and residential and commercial meter stacks. There is a need for easily accessible receptacles to provide electrical power for various types of portable construction equipment and recreational vehicles, RVs. In order to satisfy the electrical power needs of temporary service and meet the requirements of the NEC, a safe and reliable power outlet is required. Siemens All Sites temporary outlet panels provide a variety of options for UL listed power outlets suitable for use as temporary service equipment during construction or as RV power supply panels. All Sites temporary outlet panels are available for surface mounting or on earth-mounted or pad-mounted pedestals in single panel or back-to-back configurations. Unmetered and ring-type and ringless metered versions are available in all configurations. Okay, well that concludes part 4, so let's take a quick knowledge check. Siemens blank series load centers are convertible from main breaker to main lug and vice versa, have copper bus bars, have ground bus bars, have dual neutrals on all configurations, and come with a lifetime warranty. Is that A, the PL series load center, or B, the ES series load center? Question 2. Siemens blank series load centers have aluminum bus bars, have single-sided neutrals up to 24 circuits, and come with a 10-year warranty. Is that A, the PL series load center, or B, the ES series load center? Question 3. Both PL and ES series load centers have Siemens patented blank screws on neutral and ground buses. Is it A, fast wire, B, InstaWire, C, quick wire, or D, rapid wire? Question 4. Siemens EQ product line includes which of these types of products? A, 300 to 400 amp load centers, B, small circuit load centers, C, circuit breaker enclosures, or D, all of the above? Okay, last question. Siemens generator ready load center is a blank or blank amp 30 circuit 42 space load center that provides an effective solution for implementing generator backup of critical circuits. Is it A, 100 and 150, B, 150 and 200, C, 200 or 225, D, 300, 400? Okay, well, this concludes the Siemens Quick Step Basics of Load Centers course. In order to complete the course, you must take a final exam and score 85% or better on the following questions. So let's get started. The basic requirements for a panel board are given in NEC article. Is it A, 230, B, 408, C, 310, or D, 410? The two types of enclosures available for Siemens load centers are NEMA types A, 1 and 12, B, 12 and 4X, C, 1 and 3R, or D, 3R and 4. A component used in a load center that serves as a common electrical connection for multiple circuits is A, the interior, B, the trim, C, a bus bar, D, a knockout. Siemens PL and ES load center sizes range from 12 to blank circuit/spaces. A, 36, B, 42, C, 54, D, 70. Two major categories of load centers are A, main breaker and main switch, B, main lug only and main switch, C, main breaker and main lug only, or D, main breaker and main contactor. The most common distribution system used in U.S. residential application is A, single-phase 2-wire 120 volt, B, single-phase 3-wire 120 to 40 volt, C, 3-phase 3-wire 480 volt, or D, 3-phase 4-wire 208 120 volt. The NEC specifies that for each set of service entrance conductors, no greater than blank switches or circuit breakers can be used to disconnect and isolate the service from all other equipment. Is it A, 1, B, 2, C, 4, or D, 6? The neutral conductor is blank, bonded, or grounded at the service entrance load center. Is it A, never, B, rarely, C, often, or D, always? The blank method requires the main circuit breaker to be capable of interrupting the available fault current but allows downstream circuit breakers to be rated at lower values? Is it A, series rating, B, withstand rating, C, full rating, or D, interrupting rating? Blank circuit breakers, in addition to providing overcurrent protection, are intended to protect downstream wiring from three categories of arc faults: line to ground arcs, high energy parallel arcs, and series arcs greater than or equal to 5 amps. Is it A, GFCI, B, combination AFCI, C, branch feeder AFCI, or D, all of them? Load center is an industry term that applies to the types of blank used in residential or light commercial applications. A, switchboards, B, panel boards, C, control panels, D, meter centers. Blank are undesired arcs in which current flows in unintended ways, but in residential applications, usually not in sufficient amounts to cause a standard overcurrent protection device to trip. Is it A, voltage faults, B, ground faults, C, arc faults, or D, overloads? A 240 volt circuit requires blank spaces and a load center supplied by a 3-wire 120/240 volt supply. Is it A, 1, B, 2, C, 3, or D, 4? A blank circuit breaker can be used to replace a 1-inch width circuit breaker when an extra branch circuit is required, but all of the load center spaces are already used. Is it A, full size, B, 2-pole, C, GFCI, or D, a QT duplex? Ground fault protection is required in which of the following areas? A, bathroom receptacles, B, bedroom receptacles, C, living room receptacles, or D, family room receptacles? Siemens PL load centers, A, have copper bus bars, B, are convertible from main breaker to main lug and vice versa, C, have dual neutrals on all configurations, or D, all of the above? Siemens ES load centers have blank bus bars: A, aluminum, B, tin finished copper, C, silver finished copper, or D, aluminum or copper? Siemens EQ circuit breaker enclosures and small load centers are available in a NEMA blank type enclosure. Is it A, 1 or 3R, B, 4, C, 4X, or D, 12? Okay, final question. Siemens blank incorporate a meter socket enclosure and a main circuit breaker or provisions for a field installed main breaker. Is it A, main breaker load centers, B, main lug only load centers, C, circuit breaker enclosures, or D, meter mains? Well, that concludes our quick step basics of load centers course. Hopefully you got something out of it. Thank you very much for completing the course, and be on the lookout for more Siemens quick step courses in the near future. Thanks again.